Hey guys, welcome back to another video, and for this video I'll be showing you guys how to do a Durbin Watson test for autocorrelation by hand. Well, not necessarily by hand, since I'll be using the computer for to calculate the necessary values. So first of all, we want to know that we can do a Durbin Watson test for positive autocorrelation. And the null hypothesis for that would be the error terms are not autocorrelated, while the alternative hypothesis would be the error terms are positively autocorrelated. And we can do one for negative autocorrelation, where the null hypothesis would be the error terms are not autocorrelated, and the alternative hypothesis, the error terms are negatively autocorrelated. And also we can do a Durbin Watson test for positive or negative autocorrelation if we do not want to do a specific one. And that null hypothesis, the error terms are not autocorrelated, and the alternative hypothesis is the error terms are positively or negatively autocorrelated. So now let's look at the test statistic. We have a test statistic D is equal to the summation of T equal to of ET minus 1 squared divided by ET squared. Now our ET is the residual, the ordered residual, not necessarily ordered, but the time residual, and that is given by Y minus y hat, where our y is our observed value, and our y hat can be given from the linear model equation, where we have y is equal to alpha plus beta x. So now let's show an example using let's calculate the values using R. So here we have R. So I have a data set already, so I'm just going to load in the data set. Let's call it file is equal to dot table So let's have a look at our data set. And our data set looks something like that. So now we're going to create a linear model. Let's call our linear model mod, and equal to lm y regressed against x, and we're taking it from our data is equal to file, close bracket, enter, and let's view our linear model. There we have our linear model, where our intercept is 4.514 and our x is minus 2.249. So if we should do a Durbin Watson test now, we would have to load a package called lm test. So let's go ahead and load that package. lm test, and there we have our package loaded. So now we can go ahead and perform a Durbin Watson test using the function dw test on mod, and we have a Durbin Watson test statistic of 2.0094 and a p-value of 0.5131. So this is basically saying there is no positive autocorrelation or autocorrelation in our data, but let's go ahead and calculate this now by hand. So if we say resid, let's name our residual values, that's our all our e values, as R E S D, and RESID of our model. Let's view it. Then those are our residual, but let's put it in a data frame. So we can say data.frame and RESD, and there we have it in a data frame. So now we can go ahead and copy these residual values and start working on calculating by hand. So let's go ahead and do that right now. And we're just going to paste it in Excel so that our calculations can be easier. So in Excel, we need a table for our E values, our ET minus 1 values, and that should be all squared, but let's create another column for that. So we can go ET, let's call it ETT squared, and we need a column for just ET squared. So our E values are are given by these values here, and now we'll just go ahead and minus our ET minus or ET minus or ET minus 1, and we can just see equal this guy right here minus this guy right here equal, and that's our value, and we can just drag it down and we'll get our values. And now if we should square it, we can just see equal this guy and square and equal our value. So now for our ET squared, which are all of these guys squared, so we can just say equal this guy squared equal, and just pull down our cursor. So now we can calculate our D. So D is should be equal. Let's just D should be equal to the sum of all these guys, all ETT R squared divided by ET squared, the sum of ET squared. Let's go ahead and sum that first. So the sum of this should be equal to the sum bracket this guy all the way down here, close bracket, enter. So that's 524.302, and now the sum for ET is just equal the sum bracket this guy down to this guy, and enter. So here we have 250.1456. Now our test statistic D will be equal to this guy divided by this guy right here, and that will just be 2.095987. We can know that there's a small insignificant difference in the values where we calculated it in R. Here we have a value of 2.0094, and here we have a value of 2.095987. That's negligible, and it can be attributed to corrections within R. So here we have our test statistic being 2.095987, and we want to test for positive and negative autocorrelations. So we'll just go back to our initial hypothesis and our rejection region to see if we can accept or reject. So for Durbin Watson test for positive autocorrelation, our rejection region is if the test statistic D is less than DL of A, where A is the significance level, we're going to reject the null. And if D is greater than DU or A, alpha rather, we do not reject the null hypothesis. And if D falls in between those two intervals, then the test is inconclusive. So what we're going to do now is look at our Durbin Watson table. So our Durbin Watson table should look something like this. This is the 1% significant points of the DL and DU, where N is the number of data points in our data set, and K is the number of predictors including the intercept. And in this case we have one predictor and the intercept. That means in this case K is 2. So if we're testing at the 1%, or even let's say we're testing at the 5% level, since our default is the 5% level, let's use the 5% level. So say we're testing at the 5% significance level and we're looking at DL, then we have N being 18 and our K being 2. Therefore our rejection region would have a value of 1.046. So remember that value, 1.046. If D is less than DLA, we reject the null hypothesis. So in this case, D is not less than.
So D is not less than 1.046, and therefore we cannot reject our null hypothesis, saying that there is no positive autocorrelation. And then we can go ahead and check for negative autocorrelation, and then we can come to a standard conclusion that there is no autocorrelation between the variables.
And we can just continue using this preamble to test for negative autocorrelation using these rejection regions. And if we're testing for the Durbin Watson two-tail, let's call it a two-tail, for positive or negative autocorrelation, then we'll have to divide our alpha by 2, and we can use either of the rejection regions for the positive or negative autocorrelation. So thank you guys for joining. I'll see you in the next video.